Welcome student in our YouTube channel Physics by T C Chauhan Sir. Today we are going to discuss Gauss theorem and its verification. What about Gauss theorem and what about its verification? Let us discuss about that. Gauss theorem is a theorem which is given for determination of electric flux due to a particular system of several charges present in a particular closed surface. It is a 3D surface in which several charges Q1, Q2, Q3, Q4, Qn are lying or situated. Then we have to find the net electric flux passing through this surface. This closed surface is known as Gaussian surface. It is known as Gaussian surface. The net flux through closed surface will be phi is equal to sigma q upon epsilon naught. That is, the net flux through a closed surface is 1 upon epsilon naught times the algebraic sum of charges present in the Gaussian surface. That sigma q is algebraic sum of charges q1 plus minus q2 plus minus q3 dash dash dash. It can be represented for a particular medium. If there is dielectric medium present, then it can be represented as phi is equal to 1 upon epsilon sigma q, and you know the value of epsilon is epsilon naught epsilon r sigma q. Epsilon r is dielectric constant. This is Gauss theorem. It can be written in this way. If you know, phi flux is represented as phi is equal to integration of E vector dot dA vector. That is electric flux, and it is sigma q upon epsilon naught according to Gauss theorem. So it can be represented in this way also. In the case of medium, this epsilon naught can be represented in terms of epsilon only. This is about Gauss theorem. Now, how to prove this Gauss theorem? What is the verification? Proof. If you want to prove this, you take a point charge q and you take an observation point p at a particular distance small r, and then a closed surface is taken, and that closed surface is spherical. Here electric field intensity will be E vector, area vector will be dA vector. Both are in same direction, so angle theta will be 0. In this case, you know electric flux phi is equal to integration of E vector dot dA vector, that is closed integral, you know, it should be in the closed surface only. Then phi will be integration of E dA cos theta. Then what about E? That is, you know, kq upon r square. It is dA cos theta is cos 0 because angle between E vector and dA vector is 0. Then what about flux? Phi is equal to, this k is taken as 1 upon 4 pi epsilon naught, and this q upon r square cos 0 is 1. There will remain integration dA. dA is a small area which we have assumed on the surface, on a spherical surface. When integration is taken, the whole surface will be there, and the area of total spherical surface, that is surface area of sphere, is 4 pi r square, that you know. That is integration of dA is equal to 4 pi r square. Then phi will be 1 upon 4 pi epsilon naught q upon r square into 4 pi r square. Pi will get cancelled, 4 will get cancelled, r square will get cancelled. Q upon epsilon naught will be there. This is for single charge. If several charges are there, then phi will be sigma q upon epsilon naught. This is proof of Gauss theorem. Now, what are the properties of Gauss theorem? Listen, this surface, closed surface, is known as Gaussian surface. Second, the flux does not depend upon shape, size and nature of Gaussian surface. Next, the flux does not depend upon distance between charges present in the Gaussian surface. Then the flux will be 0 if net charge will be 0. If any charge is situated outside Gaussian surface, it is not taken in the flux calculation. If the net charge is positive, then flux will be outward. If net charge is negative, then flux will be inward. If there is medium present, then electric flux will be affected. This is all about the electric flux due to Gauss theorem and proof of Gauss theorem. So this session become very useful for you, I think. You please do subscribe our YouTube channel Physics by T C Chauhan Sir. Thank you very much.